Deze video, en eigenlijk is het alleen audio, hoort bij een podcastserie die ik, Frans Pollux, maakte in opdracht van Human voor NPO Luister. Het is de serie Het Apparaat, waarin ik op zoek ga naar een heel maf apparaat dat de wetten van de natuurkunde schijnt te tarten en misschien wel een bron is van eindeloze energie. En die zoektocht brengt me uiteindelijk naar Canada, naar de uitvinder THANE HEINS. We hebben lang met hem gesproken en maar een heel klein stukje van die gesprekken kunnen gebruiken in de podcastserie zelf. En ik wil hier de ongemonteerde, volledige gespreksopname droppen. Het is lang en het gaat heel diep in op dat apparaat dat hij heeft bedacht, maar doe er je voordeel mee. Veel plezier met THANE HEINS uit Wendover, Canada.
It's an honor to meet you, Mr. Heins, finally. Because I've been thinking about meeting you for a month. I thought when my story about the machine in Venlo will not turn out to me meeting the guy, or I think maybe I can go to Canada and meet Mr. Heins and he explains me his machines, because in the end it's all about electromagnetism. The thing in Venlo is the other machines I discovered in Turkey and also it's electromagnetism. That's the core of the things you discovered. Well, maybe 15 years ago, 20 years ago.
Well, the core discovery that people are finding out about now is that electromagnetism is not just electromagnetism. Electromagnetism is electromagnetic field energy, and electromagnetic field energy is a form of energy that is created. So
on a subatomic level.
Electromagnetic field energy is created at the subatomic quantum electron level when electric current flows in a current-bearing wire. Mm-hmm. So the reason that all these people are focusing on electromagnetics is because there are ways to tap into the electromagnetic field energy in order to perform various types of work. So,
which is revolutionary, because that's not what we're used to do.
No, it's not revolutionary at all. It's just that our explanation of it or our understanding of it is incomplete. Okay, so every electric car that's on the road today, and every hybrid, and even your gas-powered car, is harnessing electromagnetic field energy in various ways to perform different types of work. Okay, so an electric vehicle during regenerative braking is harnessing created electromagnetic field energy in order to perform negative work, which decelerates the car during regenerative braking.
Can you explain this to Miel, if he's...
Okay.
See if they have a pencil inside or a piece of paper.
Let's do this. This is like, I'm going to introduce you to negative work, okay, being performed at infinite efficiency, okay?
Which is crucial.
Well, it again, once you start getting into the explanation, it becomes more and more interesting, okay? So here we have an electric generator, okay? And what I want you to do is I want you to turn this electric generator, okay? And I want just keep turning it at a steady state speed, okay? So go ahead and do that.
Het ding is ongeveer 20 centimeter lang.
20 centimeter denk ik aan. Er zit een
soort cilinder aan, een draaiknop.
Een knop van een centimeter of 4 doorsneden.
Okay.
Waar ik aan moet draaien. Alright.
Okay, so just keep it going at a steady state speed. Okay. Now, not too fast. Just
right.
okay. So right now the generator is on no load. Okay?
No load.
No load. It's not. There's no current flowing. It's not. You're just idling the generator on no load. Okay.
Right.
Now I'm gonna place the generator on load. Okay, and you are going to violate Newton's first law. Are you ready?
I guess so.
Do you want to violate Newton's first law?
Yeah, I'll be happy to.
Okay. So
De eerste wet van Newton gaan we nu overtreden. Dat is
So he's rolling over in his grave right now. So keep going. Now I want to explain to you how Newton's first law works. Okay. So Newton's first law says, you need to keep going. If I do this, okay.
So hij put zijn vinger on it. Hij houdt nu met zijn vinger dat ding wat jij moet draaien tegen. Hè? Dat is frictie.
What I'm doing, Newton's first law says that the change in inertia of the rotor, okay, the change in inertia of the rotor is accompanied by an external unbalanced force. Okay,
You're applying a force.
I'm applying a force which is resisting the rotation. My finger is performing negative work. Okay, like
And does it cost energy?
yeah, well, it requires energy. Okay, so if you keep going like that, and if I said I'm going to slow that, I'm going to slow that down, but I'm not going to use energy. I'm going to use voodoo or witchcraft or whatever. You might say, okay, well, good luck, right? But in order to slow that down, I need energy. I need to, I need to apply energy to it. Okay.
Right.
That's Newton's first law, and that's the first law of thermodynamics. In order to change the kinetic energy of this thing that you're turning, an external force needs to be applied,
Right.
and external energy needs to be used to apply that force. I mean, I'm using the energy in my body. So now what we're going to do is we're going to change the kinetic energy of that system, but we're not going to be using any external energy
Right.
or any external force. We're going to use internally created electromagnetic field energy. So keep going.
And now you're connecting the wires attached to the...
Current is going to flow through the coils, and when that happens, the electromagnetic field energy around the generator coils
We'll slow the
is, well, wait till you see.
Yeah, exactly.
Wat gebeurt er?
I can hardly move it.
You can hardly move it.
Right.
Okay. Now let's show you something else.
So just let me explain this. En,
Yeah.
Dus wat er nou gebeurt is, hij maakt een, hoe noem je dat? Er komt stroom op de elektromotor.
Hij zegt
Ja?
dat er stroom gaat lopen door een coil, hè, dus een
Koperen draad
spoel,
gewikkeld.
een spoel
Ja.
van draad. En dat creëert een magnetisch veld. En dat zorgt ervoor dat ik met veel meer moeite
Ja.
die draaiing kan doen.
Dus zijn punt is, want er zit verder geen externe energiebron nu aangesloten.
Hij zit nergens aangesloten, toch?
Nee.
Ja.
Dus zijn punt is, wat hij normaal met de vinger moet doen, dat kost energie, jou afremmen.
Ja.
Nu doet hij het niet met zijn vinger, maar doet hij het alleen door een elektromagnetisch veld te creëren. En dat remt je af.
Ja,
Dus dat afremmen van jou kost energie.
dat is
Maar
wat hij claimt. Maar ik zou denken dat het elektromagnetisch veld creëren met die spoel, daar moet je stroom voor op die spoel zetten.
dat is dat jij draait. Of niet? Dus how is the electricity in the wire, has that something to do with him turning the...
So
Because he's turning and...
yeah, right now you're generating a voltage in the coils.
Right.
Okay. But
I'm turning magnets.
there's magnets and then there's coils in here.
Yeah.
Okay. But
It's the magnets turning is creating an electric.
the magnets that are turning past the coils,
Right.
they're inducing a voltage in the coils according
Right,
to
Right.
Faraday's law of induction.
Yes.
Okay, and Lenz's law of induction is a minus sign in front of Faraday's law of induction, which says that the created electromagnetic field energy performs negative work. And you can feel it, okay? So, let's do the math.
Er zit een meter op aangesloten, dan zitten
This is
twee
the
meters.
current, and that's the voltage.
Right.
So, just take a rough, let's say 0.3.
Something like that, yeah.
0.03 volts
Is what he is creating by turning the wheel.
at 0.3 amps. Okay? So the power that you're producing here in watts is minuscule, right?
Right.
Right? It's like so small. Now, imagine the. Okay. Just hang on a second here. It's. What did we say it was? 0.03
Yeah, 0.03 and 0.3 here.
times 0.3 is 0.009 watts.
Right.
And how long would it, like it's almost impossible.
I'm getting a bit tired now.
Yes,
Yeah, right.
yes. Now imagine, that's 0.009 watts. Imagine if you were generating 27,000 trillion watts of motherfucking electricity. Imagine
I'm hearing the suspense music now under your voice.
Imagine how much if you were generating 27,000 trillion watts of electricity here, and this is what I said to you in the email, this is what you're going to be exposed, pay attention to this. You need 27,000 trillion watts of mechanical input power to generate your 27,000 trillion of output.
Yeah.
Now,
Which makes sense.
yes,
For me. Yeah.
yes. And if you're using fossil fuels like we are to generate 16,000 trillion watts of that electricity, okay, the rest is wind and hydroelectric and solar and whatever, you're producing 16,000 trillion watts of electricity, but 16,000 trillion watts, mechanical watts worth of air pollution and CO2, okay, which is killing the planet. It's what it's doing. Now, just imagine, turn it again. So this is a Faraday generator, okay? A regenx generator, and which
That's the thing you
hopefully
built.
we'll be able to show you that tomorrow. The regenx generator, it's patented and replicated. What it does, so what happens, you can stop for a sec. What you're turning the generator in the
Anti-clockwise.
well, let's say, okay, turn it in the clockwise direction.
Yeah.
You're turning it in the clockwise direction. When current flows in the windings, the created electromagnetic field energy inside the current-bearing wires, it produces a counter electromagnetic torque, which you felt, okay?
Right.
You felt it, right? And it's trying to turn the generator in the counter the counterclockwise. Yes.
If you press the finger hard enough,
Yeah.
then the forces balance
Now,
out and the thing
okay,
is
keep going. Now I'm adhering to Newton's first law. Okay.
Putting your finger on it again.
Yeah.
En nu haalt hij de vinger weg en doet hij het weer met de stroom.
Now we're violating Newton's first law
Because this is...
because Newton's first law says the energy has to be external.
Yes.
It
I
can't.
understand.
It
Yes.
can't be internal. If it's internally created, well, now you're violating the law of creation of energy.
Because he would break with his own energy he's putting in to make it move.
Well, it's creating its own energy that it needs to perform the negative work. So the
It's
kinetic.
because there are magnets in there, right?
No, it's because
I move the magnets.
no.
That generates the
No.
current.
It's because current is flowing in the windings. If this was if you replace the magnets with electromagnets, the process would be the same. So we are generating electricity in the generator, and the current that's flowing through the windings is creating the electromagnetic field energy that is performing the negative work that's reducing the kinetic energy of the system, which you felt. Okay, so that's EV regenerative braking. That is the classical engineering term is generator armature reaction. So when I was 19 years old, sitting in my motors and generators class in college, the teacher introduced us to generator armature reaction, this counter electromagnetic torque, and that's what it's called. And I was 18, 19, whatever, and I was studying physics before I transferred over into the electronics program. And so when he said counter electromagnetic torque is work. Okay, if you've ever used a torque wrench or a ratchet or whatever to put a nut on, you're applying torque, but you need energy to apply torque. So when he said counter electromagnetic torque, I put up my hand and I said, Professor, where does the energy come from in order to perform the counter torque? Because torque is work and work requires energy. So what's the energy source that's required to perform the torque? And he couldn't answer the question. And
So the standard explanation for this familiar phenomenon is there is no explanation.
well, there is an explanation, but the scientific community doesn't want to hear the explanation, because the explanation is that the energy is being created.
In the electromagnetic field.
No, the electromagnetic field is the energy, but it's being created at the subatomic quantum electron level when electrons. So what's happening when you are inducing a voltage into the windings?
Wat er gebeurt als je draait?
You're inducing a voltage into the windings. As soon as you put it so that it's a closed circuit, okay, now that voltage, the voltage is called, classical term, is electromotive force, okay? It would be better if they called it an electron motive force, because what happens then, because now the electrons have a route to go,
So they travel.
they're not, it's not an open circuit, so now they
Hij maakt het kringetje en dan kunnen die elektrons rondgaan.
Ja,
hè?
dat is-
Stroom, dat is stroom.
now the electrons travel through the wire, and the electron motive force or voltage is forcing the electrons, which are in what's called the valence orbit around the atom's nucleus. So the valence orbit, where those electrons are, they're loose. They're at the outermost edge of the orbit, the orbit around the nucleus of the atom. So they're easily forced out by the electromotive force, and they leave one atom and they cascade to the next atom, and when they drop back down to their valence orbit again, they create and release photons, which is energy. They release energy.
They generate an electromagnetic field, you
And
could say,
then
right?
The electromagnetic field is is created by and constituted by photons. So if you looked at the electromagnetic field around the wire, it's photons. Okay?
Well, it's electromagnetic radiation, right? And
that's what all electromagnetic radiation are photons.
exactly right.
And photons are the force carrier for the electromagnetic field. The force carrier, okay? So here's my finger, which is the force carrier for Newton's first law, and the force carrier in the electromagnetic field, that's the thing that's performing the work.
Yeah. So it's not like
applying a force, right?
Sorry?
It's applying a force.
It's applying a counter electromagnetic torque, a counter force, and it's performing negative work. It's really important to understand that, like, if you're turning this at, let's say, I don't know, 10 RPM, 20, whatever it is. Let's say it's 10 RPM.
10 rondjes per minuut.
There's a certain, let's say the kinetic energy is 10 joules, just for argument's sake, okay? The kinetic energy is 10 joules. So then I connect it, and now it's harder to turn. Now you're turning it at 5 RPM, and now the kinetic energy is 5 joules. Okay, just for argument's sake. The negative work performed by the generator is 5 joules of negative work, because it's performing negative work, which is the kinetic energy reduction is equal to the magnitude of work performed, the magnitude of negative work, which is equal to the magnitude of energy required to perform that work. And it's all in joules. So
can I ask a dummy question for me? So I first ask it to him and then in English. Dus dat je als je draait, je draait en je kunt hem bewegen, maar vervolgens verbindt hij die draadjes en dan creëert hij stroom eigenlijk.
Dan gaat er een stroompje lopen.
Ja, maar dit creëert door te draaien, toch?
Ja.
Ja, dus dat draaien van jou, wat eerst alleen zich vertaalde in de beweging, jouw energie vertaalt zich alleen in de beweging, maar nu beweegt dat ding, maar wordt er ook iets gecreëerd.
Ja, dus je hebt beweging.
En iets anders, dus daarom is het moeilijker om hem te draaien.
Je hebt beweging, je hebt magnetisme en je hebt elektriciteit. En als ik... hier zitten magneten aan vast. Dus op het moment dat ik ga draaien, dan draaien die magneten in die spoel. Dan draait er een magnetisch veld.
Ja.
En dat genereert een stroompje.
Ja, maar is het niet logisch dat zo gauw het ook een stroompje genereert, dat jou dat meer energie kost? Want je moet hem dan en laten draaien en je wekt energie op.
Exact, dus ik zet eigenlijk kinetische energie om in stroom.
Ja, maar dus moet jij meer... Dus kost het meer energie om hem rond te draaien? Of is dat een hele rare...
Ja, precies. Ja?
Oké. The dummy question.
okay.
If I turn this around without the wires connected,
Yeah.
the thing inside is turning around, and that's the kinetic energy which I am putting in by my hand. But the moment you connect the wires,
So the first one was no load.
right,
Okay.
and so no load,
Our terms correct.
and then you
Unload.
unload.
Yeah.
And isn't it reasonable that it's more difficult to move it because I'm not only rotating the inside, but I'm also creating electricity. So that's the reason why it's...
You're creating electromagnetic field energy, which is working against you. You're creating electromagnetic field energy inside the, around the, if you could see in there, you'd see the coils.
Right.
And around the coils, electromagnetic field energy is being created, which is like putting the finger on the magnets that are turning. Okay, they're decelerating. They're trying to stop you from turning the generator.
Yeah. So, but I am creating this force with my
You have to.
energy.
So, okay, so on no load, okay, it's very easy to turn the generator. And if you generate, let's say 1 watt of electricity, as soon as you generate 1 watt of electricity, you need to increase your mechanical input power to the generator by a minimum of 1 watt.
Right.
So 1 watt out.
Yeah.
But
So I would say or think that I'm applying kinetic energy. I'm applying a force that makes the thing turn.
yes,
And the moment you connect the wires,
the moment you put it on load,
that energy is converted to electronic energy or to electricity.
which
that-
energy?
The energy I'm applying, and we could do it the other way around. You could put it in the
So you're-
socket,
okay.
and then you could make it turn.
Okay, so you're applying mechanical input energy, okay, which can come from you or a wind turbine, or the kinetic energy of an EV that's going down the highway.
Right.
And when the generator is placed on load, because it performs negative work, because it produces a counter electromagnetic torque, you have to, it's called generator armature reaction, okay? You have to react now and increase your mechanical input power to maintain the speed of the generator. Otherwise, it will stop.
Yeah.
Otherwise, it will. If you didn't, like, if
So I would think it's just turning one type of energy into the other.
uh,
Right? It's turning kinetic
yeah, but you
energy
can't.
into.
There is no facility to turn mechanical energy into negative work, like in the generator. You have
So that it is a negative force. That's the clue. It's because it's negative work.
well, so I'll explain the regenx generator, which hopefully I'll be able to show you tomorrow.
Yeah.
So the regenx generator, if you're turning this,
Dat is wat hij heeft uitgevonden.
if you're turning this on no load, and then when you connect it, the generator turns, the generator produces a complementary electromagnetic torque.
Instead of
A counter,
acting against it.
it goes in the same direction.
Right. Okay.
So it gets easier to turn,
By
and
turning it. Right. Yeah. You turn it, and it gets easier.
it gets, well, in the regenx generator mode, this is it here, it gets easier to turn, and you need less mechanical power than you do on no load when you're generating electricity with a regenx generator. And the more electricity you generate,
The easier it
the
becomes.
easier it becomes.
So it gets faster and faster and faster. and
It
faster.
goes faster and faster and faster. That's why it's called, in an EV, it's called regenerative acceleration. And what it does is when it's recharging the EV's batteries, it's accelerating the car.
So it's accelerating the car and recharging the battery at the same time.
And it's performing positive work and accelerating the car. The generator would be accelerating your hand.
Right.
And so this was the discovery that I made in 2007.
And what did you discover that made this work?
I made a
What is the underlying principle that you discovered that makes it happen?
The underlying principle is that I created the windings that are in this generator. They are what are called high current windings. Okay, they're designed to to produce a lot of current, and so if they produce a lot of current, they produce a lot of strong electromagnetic field energy. So, and a strong counter torque. Okay, so I was looking for ways to reduce the counter electromagnetic torque. That was the that was the function of our research that began in
Making the generator more efficient. That was
making it 10% more efficient.
So for me to understand, that means you would turn it, it would generate the current,
Yeah.
but I wouldn't feel the pushback as much as I'm doing now.
Yeah, you would need 90% increase in mechanical rather than 100%.
While it would still make the same current.
Yes, yes. So and that was the question. That was my follow-up question when I was 19 years old, when I said to the professor, where does the energy come from to create the counter-electromagnetic torque? Which he couldn't answer. And again, if you can talk to any physicist or any electrical, they won't be able to answer the question because they don't know the answer. And I'm giving you the answer today. So the follow-up question to the professor was, sir, and he went on to explain that the electromagnetic field that was created around the generator coil was resisting the rotation of the generator's rotor. So he was explaining, he was answering my question, but he wasn't using the term electromagnetic field energy. See, if you use the term electromagnetic field energy, if you just say electromagnetic field and stop there, it's not complete. If you say electromagnetic field energy, now that energy is being used to perform negative work, right? Now, in our system, we're using that electromagnetic field energy to perform positive work. And it's extremely, it's like, this is why we went to MIT. We went...
How can you flip that around?
I'm going to get to that in a second. So, in 1980, when I asked the professor, I said, sir, what about if it's the magnetic field that's entering the air gap between the rotating magnetic field and the generator coil, and that's slowing down the rotor, what if we could somehow divert that magnetic field away
In such a way that they get aligned? Or
well, they're just divert it out of the way.
Right.
Just divert it so there's less of it doing less negative work.
that will make it more efficient.
Yeah. And so he said, and these are his exact words, he said, okay, THANE, he was getting tired of my questions by this time. And he said, okay, first you're going to have to violate Newton's first law, Newton's third law, Lenz's law, the law of conservation of energy, and the first law of thermodynamics.
All laws.
Yeah. And he said, and then he looked around the class and he said, you can go ahead and try, but we all know that you're not going to be the one to do it. So please shut up and stop asking me such stupid questions.
And here we are at the core why you
And
have
so
put
in-
40 years of your life into this quest.
In 2007, when I built a generator in the basement that accelerated, that was what was supposed to decelerate by 10% less than a normal one. That would be like colossal. Right. That would be huge. So when I built the generator and it accelerated,
You were surprised.
well, I was surprised, I was mortified because it accelerated itself so much that it destroyed itself. I mean, the magnets started flying off, started bouncing off the table.
You couldn't stop it anymore.
No, I had it on a table over there, and I had the wires over here, and I had it connected to an induction motor that was rated at 3,600 RPM. So I had it set up so that it was running at a certain speed, and then when I connected the load, it started to speed up, and I was expecting it was supposed to slow down, okay? And when I connected it, it started to speed up.
And it kept speeding up. The acceleration is infinite.
But I was standing there going, what the hell is going, like I was dumbfounded, okay? And it started speeding up, and it was over on a table over there, and then the magnets that were on the rotor were starting to fly off and hit the ceiling and the wall, and then it started to get unbalanced, and then everything got worse and worse. And so by that
stop it would be to disconnect the wires, right?
Yeah, but it was plugged into the wall over there. So I was crawling under the table to get to the plug on the wall so I could unplug it and stop it. Meanwhile, I was in my lab in the basement under the living room. My wife started to come down the stairs, and she wanted to come into my lab because she could hear the magnets hitting the floor. They were watching TV, and she came down. She said, "What the hell's going on down here?" And I said, "Don't come in my lab, you'll be killed." The magnets were like big 1-inch magnets, and if she got hit in the head,
Like a bullet.
yeah, like David and Goliath, And I said, don't stay out of here. And I was under the table by this time, trying to get to the plug to unplug it so I could stop it. And so after that experience, I put it all back together, and this time I had the plug over here where I could unplug it easily. And I tried.
Your wife was happy with this?
Well, that was my research. That's what I was doing.
All right.
So I was the primary investor. So that was my work.
But did you think when that happened, did you realize this is going to change the world?
No, I thought it was bullshit, and I tried to get rid of it. So I said, this is not supposed to happen. This is not what I want. So for the next 2 weeks, I tried to get rid of the acceleration phenomenon.
You couldn't explain it, and it was weird. You thought it was an error.
After the electronics program in college, I did two jobs in the field. One of them was at Ottawa U as a prototype builder, as an electronics technologist, and the other one was a motor technician at the paper mill, like literally that's across the other side of the river. Okay, so I was a motor technician in the paper mill, and I rebuilt motors and fixed motors and installed motors and everything. So my immediate assumption was that the motor, there must be a short in the motor, or something was wrong. Something was wrong with the motor. That was the only explanation I had. So I took the motor all apart. I looked at all the windings. I couldn't find any issue. And then when I put it back together, I looked at the input to the motor to make sure that in order for the motor to make the system go faster, the power consumption of the motor has to go up. But when I put it all together, put it all back together and ran the test again under more controlled and safe conditions, I noticed that the input to the motor was going down. It wasn't going up. It was as it went faster, the input to the motor went down. So that was a pretty big violation. That was a violation of the.
So you are saying you invented this by accident, but you were trying to do something else, and then
it gets worse. The story gets worse. So when I was making my coils, I knew enough that the generator coils had to be high current coils. Okay, so at that time there was a store here called Radio Shack. Okay, and they used to sell what's called magnet wire. Okay, to make a generator coil, you need magnet wire, which is wire that's insulated with enamel, so that the windings are insulated. Okay, like this, but it has paint on it so that you can wind it and make a generator coil. And they used to sell a 3-pack of magnet wire. So like, I don't know, maybe like 10 gauge and 15 gauge and then 30 gauge. 30 gauge is the really thin stuff, like human hair, a little thicker than human hair. So I made, from 2005 to 2007, again, the idea was to divert the magnetic field out of the air gap. Okay, that was the basis of my research.
Out of the air gap, snap je dat?
Out of the air.
So between the magnets and the coils, that there is of course some space.
The rotor, the rotating magnetic field, and the generator coil, there's an air gap. Okay, it's like 16 thousandths of an inch. It's very, very small. And what my research was focused on was finding a way to take that magnetic field and get it out of there before it hit the rotor. Okay, and so what I did was I made.
Let me understand. So at first, this kind of accidental discovery happened. You tried to get rid of the effect of acceleration, but now at this point in your story, you were.
This is before I made the discovery.
Oh, before the okay.
Yeah, this is the even sillier part. So I used to go to Radio Shack and I used to buy
The coils.
the
wires.
magnet wire,
Yeah.
and they were small packages. Okay, so I would go to a Radio Shack, and I would go in. I'd buy all the magnet wire they had on their shelf, and then I would leave, and then I would use there was the gold one, that was the thick wire, and then there was the green one, which was a little bit less thick, and then was the red wire, okay, which was very fine. And so I would use the gold and the green, and I would throw the red wire in a box, okay, and
Because it came together in a package. And
three.
You couldn't use it, so.
It was too small. It wasn't suitable for what I wanted.
Yeah.
So I would go in and buy all the magnet wire that they had, and then eventually I had to go. I was living in Almont, and so I would go to Ottawa. I would go to Canada, and I would have all this. I would have all this because I was making hundreds of coils.
And this was before you could order them online.
I didn't even know you could. I didn't even know you could order it online. Okay, so and a big spool, like I was so uneducated. I didn't know much. So I would go around and go in the store and take all their magnet wire. And then one time I went in and I got all their magnet wire, and I went to the cash, and the guy looked at me and he said, other people want to buy that shit too, And they were mad at me because I kept, as soon as they got a shipment in, I would go into their store, take all their magnet wire, and then go to the next store and take all theirs. And I was doing that for 2 years, for 2 years. And by that time I had a big box of red magnet wire that I couldn't use. And so my coil design was a toroid. It was a round core, and I had 2 coils on each side. And the rotor went this way in between the 2 of them, okay? And the idea was that the magnetic field created by each coil would stay inside the core and not go in the air gap, okay? That was the idea. So I built my coil, for example, and then
Does that mean you're trying to change the orientation of the magnetic field?
Yeah, I'm trying to keep the magnetic field in the core rather than allowing it to go out into the air gap. So that was the design that I had gotten to from 2005. Well, actually, I started in 2000 I started right after 9/11. That's a different story. And by 2007, I had my toroid version, but then I needed a normal coil to test to test my coil against performance-wise under the same rotor rotating at the same speed, blah blah blah. And it was maybe it was like Easter or something. It was the spring, and all of the stores were closed. Okay, all of the Radio Shacks were closed, and I was so impatient.
You took the red wire.
And I used the red wire, and I made, again, at that time, I didn't know why the red wire was unsuitable, but I didn't know why, but maybe it was just a pain in the ass to try to wind it because it was so fine. So I pulled out the box of red wire, and that's all I had. And I didn't want to wait 3 days for the stores to open and whatever. So I made a coil out of the red wire, and I made it extra big, like really big. And so that coil was a high impedance coil. Okay, a high voltage coil, a high impedance coil. A normal generator coil is a high current coil, low impedance coil. Okay, and the
What is impedance? Weerstand?
yeah.
So high ohm.
Well, no, impedance is AC resistance.
Resistance.
It's a high DC resistance coil and a high impedance coil. So impedance is AC resistance. Okay, so that means that the current doesn't want to the alternating current doesn't want to change direction as fast. Okay, when you have impedance, it's like
Slowing that down.
yeah, no, not slowing it down, just changing the speed at which it can alternate back and forth. Okay, so the high voltage coil also, in between the windings, okay, there's what's called parasitic capacitance. Okay, and so when you get a high impedance, high voltage coil at the right frequency of speed of rotation, the parasitic capacitance, which is non-existent in a high current coil, it becomes paramount. Okay, which means that current can't flow in the coil, and energy is stored in the parasitic capacitance of the coil, like it's a multi-parallel plate capacitor. So above a certain speed or frequency of operation, the regenx generator coil stores energy in the internal capacitance of the coil and then releases it in order to produce a time delay, to produce a load current time delay, okay, which in turn produces a created electromagnetic field energy time delay. So in this version here,
Begrijp je wat hij zegt over die rode draden? Want volgens mij is het cruciaal, maar daar raakt hij mij kwijt.
Yeah, so you were trying to make a high impedance coil, or because you used the red wires, it just happened?
because I was so ignorant, okay, the universe selected me because I was so ignorant that I didn't know that there would be a problem. And I didn't know anything. I didn't, I was learning as anything.
You just made this, then stuff happened, and now, looking back at it, or at a later point in time, you understood what caused it.
So we built the first prototype. It accelerated. I took the motor apart. I tried for 2 weeks. I tried to get rid of the acceleration phenomenon, and then I couldn't do it. But I didn't know why. I couldn't pinpoint it to my
You didn't think about the red wires?
No. So then I called up my professor from college, and I said, "Sir, do you remember the question I asked you in our motors and generators class?"
Which was 25 years before that.
Years, yeah, whatever. And he said, "How could I ever forget? In all my years of teaching, that was the stupidest question I ever heard in my life." And I said, "Well, okay, but you remember the question that I asked you about diverting the magnetic field, right?" And he said, "Yeah." And he said, "Well, I achieved something similar to that, but my generator, for some reason, is accelerating when you put a load on. And I don't know why, and I'm hoping that you can help me understand, help me figure it out." And he wasn't interested. He wasn't interested at all, and he basically told me to leave him alone again. And so we went to MIT. We went to Dr. THANE at MIT, the number one guy in electromagnetics in the world at that time.
And I've read about this. He saw it up close, and he said, "There's definitely something I can't explain with the things I know."
Yeah, we went there and we said, "Dr. THANE, please tell us why this generator is accelerating when we put a load on, and also please tell us if anybody else has discovered something similar. There must be something in the textbooks that somebody did something, and tell us what it is, tell us why it's doing what it's doing, and tell us if you think it has any commercial viability." So, and there were half a dozen of us in his office doing the demo. Government people from Ottawa that were there, and
the demo was you showed them the regenx generator.
the prototype that
and it was accelerating.
It was accelerating, and he said, "I have no idea why it's accelerating, but," he said, and
he said it shouldn't accelerate.
No, he said no. He said clearly it's accelerating. Everybody can see that. Why it's accelerating, we don't know. Does it have any commercial viability? Probably it does. But that was it. That was all. And
so like a toned down reaction, small.
Just like, let's be careful. Yes, it's doing what you say it's doing. We don't know why. It requires further investigation. Let's do that. So we
and at this point, at the very start, you were trying to get rid of the effect. But at a certain point, you must have thought,
yes,
I'm onto something.
At a certain point, I said, okay, if I can't get rid of it, Like if you can't beat them, join them. So because I didn't know why it was doing what it was doing, I thought, okay, let's see if it can be useful. Okay, so that was one of the three questions that we had for Dr. Zan. Is it real? Is it viable? And what is it? And he answered, it is viable. What it is, we don't know, and so on. So then we went to Ottawa U. Ottawa U gave us, you okay?
Yeah.
Ottawa U gave us a lab and we set up
It's a university.
Yeah. Ottawa University. And we were setting up a research collaboration between MIT and Ottawa U to figure out why this acceleration anomaly was occurring. But what none of us knew was that we were violating all those laws of physics, like all of them that professor said we weren't going to do in college. And we set up a research collaboration in order to.
And when you're talking about we, then you're
MIT and Ottawa U.
Yeah.
So
and we is you and maybe
Dr. Zan, Dr. Habash, Ottawa U, MIT.
But the handwork is just you, like the building and the concept.
Yeah, me and a friend of mine who is
Okay, yeah.
he's an energy, or he's an electronics guy, researcher guy. So we set up in the power lab at Ottawa U, and we ran a series of tests until we focused our attention to the coil. And then we realized, okay, it's the coil that is creating the acceleration. It's not the motor, it's not...
And they were still the same red wires.
Yes. Okay. In fact, one of the prototypes... one of the prototypes in the house is from Ottawa U. I built it at Ottawa U. It's still functioning. And... So the concept that we had with Dr. Zan was that we had a motor, okay, that was turning a generator, and this is our first patent actually, that the electromagnetic field energy around the generator coil, because the rotor was steel, everything was steel, okay. So the only explanation that we had was that the magnetic field energy created around the generator coil was getting into the rotor, which was steel, going and finding its way through the drive shaft into the motor and increasing the magnetic field in the motor.
Like a closed loop.
Yeah, like if here we have a magnet. If you put a big magnet on the outside here, the motor will turn faster because the magnetic field strength is stronger. So that's what we went with MIT. We said, this must be happening. And in the demo, and I can show you pictures, in the demo, in the demonstration, we had a drive shaft that part of it was plastic, okay? And what I would do is put a steel bar in the plastic tube to create a magnetic connection. And when the steel bar was taken out, it didn't work. And when we put it in, it worked. So that was the basis of our conclusion, original patent. And that's what Dr. Zan commented on. He said, if you can use this generator idea to make that induction motor more efficient, then you have a winner, because there's millions of induction motors.
And didn't you immediately think this thing works forever? It's infinite energy. It can run houses and... No, because as soon as you unplugged the induction motor, it stopped. So
And when we went to MIT, the Toronto Star, Tyler Hamilton, they heard about it.
Hamilton is the journalist.
Yeah. And he heard about it, so he was covering the story. And
He used the words perpetual motion.
when he interviewed Dr. Zan after the demo, he said, "Is this perpetual motion?" And of course, Dr. Zan was like, "Are you an idiot? Like, give me a break. We don't even know what this is." That's like saying, you know, is the Wright brothers' first airplane that flew 30 feet, is it a space shuttle? Like, come on. Like, he was pretty upset by the question. So, Tyler...
But that the journalist is thinking about perpetual motion, I would say is logical, because if you have to plug it in, but it gives more power on the outside.
The journalist is performing fake news, trying to create a sensation, something, because again, a generator is not supposed to act like a motor. It's not supposed to accelerate itself. Okay? That's like, well, now pigs can fly. Like, this is really freaky. So what we were trying to do initially was we were trying to look for a logical explanation to something that was not logical. Again, if you put your foot on your brake in your car when you're going down the highway and it goes faster, you're going to freak out. You're going to be like, what the? And your foot's off the gas, you're going to go like, what the bloody hell? So this is what we were, and we were all like, how can this be? Like, and we went to I was on my knees. I was like, we were paying him like $600 an hour for 5 hours to like tell us what it is.
But because the journalist mentioned the term perpetual motion, Dr. Zan said, not with me.
The journalist then, when we were coming back, he called me up and he said, is it perpetual motion in your opinion? And I said, same thing Dr. Zan said. I said, we don't even know what it is. So, and by the way, I don't even know what perpetual motion means. I literally I didn't know what it meant. So when somebody says now perpetual motion, okay, they don't know what they mean, okay? On our original call, I said there's
First kind, second kind.
First kind, second kind, third kind. And our research introduces a perpetual motion machine of the fourth kind and the fifth kind, okay? And a perpetual motion machines are impossible because they have to run forever, and you can't make a machine that's going to run forever.
Because of the mechanical parts.
Yeah.
But that's the limit, the mechanical side of it.
But the researchers that are out there, okay, that what they want to, the free energy guys, the whatever guys, what they want to do is what's called a self-runner, okay? One that you can connect the output back to the input and so on and so on. They want to create, and you see them on...
What's the difference between a self-runner and a perpetuum mobile?
Okay, so...
Self-runner is the first kind.
No. Perpetual motion machine of the first kind is any machine that performs work, positive or negative work, without externally supplied energy.
Okay. Yeah.
This is a perpetual motion machine of the first kind.
Hij wijst nou naar de elektromotor.
Okay. Yeah.
Do you know why? Do you agree with me?
No.
This...
You said because it performs negative
It
work.
performs negative work. It performs negative work without external energy. It's a perpetual motion machine of the first kind.
So the world's full of perpetual motion machines.
And that's what I said to you on our thing. This is why I said the universe, God, whatever you want to say, is a practical joker, and the joke is on everybody, because because this is a perpetual motion machine of the first kind, which performs negative work without external energy being supplied to it. That's the operative word is external energy. It's the energy that's performing the negative work is internally created energy. So it's not only is it a perpetual motion machine of the first kind, it's violating Newton's first law, and it's violating the law of conservation of energy. But
Because its energy source is endless. It's infinite.
well, it's created. It's limited to the size of the generator, but essentially it's unlimited in how much can be
So
produced.
you're saying this is an example of in a certain way, this is an example of a perpetual motion
It is.
machine, but it's not a self-runner.
No. Yes.
That's
Okay. That's a perpetual motion machine of the first kind. So you have one in your truck. I have one in my car. Every EV that's using regenerative braking, perpetual motion machine of the first kind. And if you go on Wikipedia, they're very careful. They say work, but work can be positive and work can be negative. Okay, so our generator performs positive work and accelerates. That's why our discovery in 2007 is so critical, because the electromagnetic field energy is performing a type of work that nobody ever thought could happen. And if we're fortunate enough that you can come tomorrow, you'll be able to see in the prototype that I made at AutoU, the load current sine wave for the conventional coil that's in the prototype, and then the load current sine wave for the regenx coil, and you can see that one of them is delayed in the time domain. So it's the delay of the current.
Right. Because of the delay, it is kind of turning into self-resonance.
Because of the delay, it's assisting the rotation rather than resisting it. So if you walk towards me and I was a Faraday coil, I would push on you to slow you down. Then when you were walking past me, I would grab on you and try to pull you back. If you're a regenx coil, I'm going to let you get to here before I do any kind of force. And I'm going to push you to make you go faster that way, and I'm going to grab you and pull you faster this way.
But the key is the delay, because that is what makes it into phase.
Time delay. It's a time delay.
Yeah.
So and that's why the over Unity guy, the Dutch engineer, that when he did his replication,
The Dutch guy I didn't talk to who built a
I don't
regenx.
even know who he is. Like he's just some anonymous engineer guy that replicated the technology.
Oh, and he's on YouTube,
Yes.
and we couldn't find the source of it. But we hear Dutch English, die heb ik in een van de eerste afleveringen gebruikt. Hoor je hem vertellen?
He did a very good evaluation, because he ran his motor at 50 hertz, and then he ran it at 60 hertz. Like at 50 hertz, it operates like a Faraday generator, okay? 60 hertz, slowing down still, 70, 80, and then when he gets to 100 hertz, now it's accelerating.
The frequency is crucial.
The frequency,
De frequency is hoe snel die draait.
Hoeveel rondjes die per minuut maakt.
the frequency, as the frequency goes up, the impedance of the coil goes up. So this coil has very low impedance in here, okay? So that means that the alternating current changes very rapidly. As the frequency, if you increase the speed of this to like 10,000 RPM, the impedance of the coil would get higher. But in a regenx generator coil, as soon as you get to a certain speed, then now the
time delay causes the whatever to become in phase, and it flips instead of slowing it down, it starts speeding it up.
What it does is the impedance of the coil delays the current's ability to flow in the coil, which delays the ability to produce the magnetic field, and it forces the coil. The coil is forced to store energy internally in the electrostatic field inside the coil. So you know what a capacitor is, okay?
It stores the...
So a capacitor is two plates with a dielectric in between, okay? And it stores voltage in the dielectric, okay? So in a regenx generator coil, the plates of the capacitor are the windings, okay? One plate, two plates, and the dielectric, the air between the windings is the dielectric. So in the regenx coil, above what's called the critical minimum frequency, and you'll see it in the Dutch replication at 100 hertz, at that increased frequency and increased impedance, now the coil, the current's not allowed to flow, okay? And the guy even shows it mathematically, okay? And so now the voltage, which is induced in the coil, current can't flow, so it has to store the energy somewhere. And it stores it in the parasitic capacitance between the windings. And in here, the impedance is so low that the parasitic capacitance of these coils is negligible. Okay, it's not even an issue. Now, parasitic capacitance becomes an issue in like cell phone towers and anything that's using high frequency. So in the regenx coil, because it's using high impedance coils at a certain frequency, that creates the load current time delay, which creates the acceleration. And if you take a regenx generator coil, and that's what you'll see, let's think positive, in the electric motorcycle, at 30 kilometers an hour, you're in regenerative acceleration mode, so you're recharging the battery and accelerating the vehicle. And below 30 kilometers an hour, now you're in regenerative braking mode. You're recharging the battery and slowing down the car. And the only differential is the frequency. Or the two differentials is the frequency, and the impedance of the coil, and the increased parasitic capacitance,
which grows with the frequency.
So we introduce a load current delay into the generator coil. So my question to the professor in 1980 was, could we divert the magnetic field out of the air gap? Not really. Not really. But could we delay the magnetic field? And when we delay the magnetic field, now we're using the created electromagnetic field energy to perform positive work.
So you don't change the direction of the magnetic field?
No.
But the electromagnetic field gets generated just a little bit later in time.
Where we're using the parasitic capacitance deliberately, voltage builds up in the coil, okay, at a certain speed, and then the dielectric between the windings, the air, can only store so much energy, okay? Can only store so much voltage. And then it stores it, and then it releases it. And once it, but
that's causing the time delay.
There's three time delays. there's the capacitor time delay, and an inductor. Okay, when you apply a voltage to an inductor, there's a 5 time constant rise time that it takes 5 time constants for the magnetic field to be fully manifested around the coil, and that's the math part that the Dutch guy does. He shows it very clearly, and so you have the 5 time constant. You have the capacitor action, okay, storing the voltage, delaying the current, storing the voltage. Then you have the 5 time constant rise time, which is increased as well because of the higher frequency and higher impedance. And then you have core hysteresis, okay? So when you have alternating magnetic field in a piece of metal, hysteresis, do you remember the tape decks we used to have, the tape recorders with the tape?
Yeah.
Okay. So
like cassette.
Yeah.
Okay.
So they store their magnetic strips that store they're magnetically charged. So they're storing information in the history of the magnetic strip. Okay, so a core has what's called hysteresis in it. So it doesn't want to change instantly as well. So when the magnetic field is trying to change direction,
all of these things cause a little bit of time delay, and if you do it just right, and you align it with the right frequency, then it kind of snaps, and then when it's
critical minimum frequency, and it's when I get home, I'll send you the Dutch guy's videos because
No, I have the video. I used it in the podcast.
Yeah,
it's an old one, isn't it?
Yeah, but the one he uses where he shows it at the first one he does from 50 hertz to 100, and then he does another one 50, 60, 70, 80, 90, 100, and the closer he gets to the critical minimum frequency, okay, the less input is required until he goes beyond the point where now it's accelerating and the input is going down. The light bulb's lighting up and it's the input to his system is going down.
If I may, so you first discovered it, you tried to get rid of the effect, then you thought maybe there's something into this. So then
I didn't know how to get rid of it.
Right, you didn't succeed in
And
getting rid of it.
nobody else knew how to get rid
Then
of
you approached people like Dr. Zahn. You tried to figure out what caused it, what the explanation was, and now you're telling us a full explanation. So how did you find out? Or Dr. Zahn said, I don't understand it.
So we went to Ottawa U and we said, okay, our goal is to figure out why this is happening. And by this time, Tyler Hamilton, Toronto Star,
journalist,
they put out their story and said THANE HEINS blah 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 goes to or Ottawa inventor goes to MIT with his blah 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 thing. Is this perpetual motion? Okay, so he asked Dr. Zahn, is it perpetual motion? No. You're stupid for asking. He asked me, is it perpetual motion? No. And you're stupid for asking.
I wrote it anyway.
But when he put the story out, he was careful not to say it's perpetual motion, but he said, is it perpetual motion to create a buzz, okay? To sell the story, to sell advertising. And in fact, I even brought it. It's right there. The Toronto Star article that they put out in 2008 was the second most read article in the history, in that year's history. The only story that beat us was Trump running in the election. So it was
It was the ultimate clickbait.
It was the second, so it was clickbait, it was fake news, and Tyler called me I was on you, he called me and he said, THANE, I'm so sorry, the editor put in the is it perpetual motion thing, the byline. So there was the headline and then the byline. And of course, as soon as, because people are emotional, as soon as Dr. Zen saw that, he was like, thank you for ruining my reputation, I'm out of here. And then all of a sudden, Luke and I, my friend, he's my business partner as well, we were the scum of the university, and we were the guys that the professors wanted to kill and kick us out and whatever. So we had to isolate down the anomaly. We had to, again, we thought it was the magnetic field. So eventually, in one experiment, we had a piece of plastic pipe that was 3 feet long, and we were still able to get the acceleration. So I said to my investors, I said, that patent that you guys spent like 25 grand on or whatever? They're like, yeah. I said, well, it's obsolete. We have to write new ones. So that's the process.
Dit was deel 1 van ons ongemonteerde gesprek met THANE HEINS, de Canadese uitvinder. Voor het complete verhaal luister naar de podcast Het Apparaat op je favoriete podcast-app.